Okay, last problem, problem number 9. These are what I call monster problems. Okay, they're formulas that involve interest rates, and they usually deal with loans. This one's a car loan, could be a mortgage, house loan, could be a loan for a yacht. Usually loans that take a little bit of time, a few years to pay off. This is a 5-year car loan. House loans are somewhere between 15 and 30 years. Right? And the mathematics behind creating this formula uses exponential theory, but we're given the formula and then what each variable in the formula represents. And what's going to happen is we're going to plug in everything we know. There's going to be one variable left, and we have to figure out the value of that variable. So it might take logs, it might take roots. It depends where the variable is. Is it an exponent or not? All right, so this part right here, you really got to read and notice where they are in the formula. So P sub n, present amount borrowed. That's the initial amount that you're borrowing from the bank to buy the car. How many months you're going to take to pay it off. Car loans are usually in months, which probably means the interest rate is in months. If you go back up here and look, monthly percentage rate. And that's usually how it goes. If they charge you interest per month, you make a payment per month. This is tricky too. Just be careful though. So the percent sign at the end here, you got to convert this to a decimal before you use it. And it's already per month. So the whole divide by 12 thing has already been done for us. Again, we just got to plug in the values. Right? Car costs $21,000 and a $1,000 down payment. And we want to round to the nearest cent. Bank wants every single cent they can get. All right, so present amount borrowed. Now in this case, the car costs $21,000, but you're putting down a down payment of $1,000. So $21,000 minus $1,000 means you're going to borrow $20,000 from the bank. Right? 5-year loan, monthly payments. So 5 times 12 months, you're going to make 60 payments on your car. Saw an ad on TV yesterday. You can now get a 0% interest car loan for 84 months. That's a long time, like 7 years interest free on a car. Monthly payment, don't have that. Interest rate per month is 0.625%. Move the decimal point 2 places to the left. All right. So that's the value that's going into the formula. The affordable monthly payment is $300 for the same time period. Determine the appropriate down payment. I think I'm missing something here. Using the formula below, determine the monthly payment. All right, so the first thing we're going to do is figure out the monthly payment. So we're going to figure out PMT, which is this value right here. So hopefully all this comes out to be a number, and I can just divide both sides of the equation by this number, and I'll get PMT. All right, so let's see. PN 20,000 equals what I'm trying to find, the payment. Now be careful, parentheses. This entire fraction's inside a set of parentheses, and on the top of the fraction, 1 minus 1 plus the interest rate, 0.0625. Raised to the negative n, monthly payments, negative 60. All of this is going to be multiplied by the payment with the interest rate as a decimal on the bottom. Like I said, this formula is derived from the exponential theory that we've been working with. All of this is just a number. There's no variables left in there. So I'm going to figure out what that number is. So let's see, I'm going to go math, no, alpha y equals, get a fraction. I don't like looking at all that stuff. So alpha y equals, let's see, 1 minus parenthesis. I could write this as 1.00625. I don't need the plus sign in there. I can do that part in my head. 0.00625. Parentheses raised to the negative 60. That's the top of the fraction. 0.00625 in the bottom. Okay. So now 20,000 equals the payment times this whole guy right here. 49.905 ... I'm going to use the whole thing. So I'm going to divide both sides of this equation by the 49. 49.905 ... 49.905 ... So I got that number. So 20,000 divided by second answer, and you get a payment to the nearest cent of $400.76. Since you're rounding and you really don't owe 76 cents every month, your last payment will be a little less than this. The bank won't make you pay extra. The affordable monthly payment is $300 for the same period. Determine an appropriate down payment. Okay, down payment. Let's see. This is a little tricky because this PMT is how much your payment's going to be, and this is how much you're going to borrow. Right? So if I want my payment to be $300, I can put $300 in here, and nothing else in this setup is going to change. You know, you're still going to borrow the money for 60 months. Interest rate's the same. Everything else is the same. So this is, it looked like it's going to be long, but it's not bad because you're trying to figure out your down payment, which means you got to figure out how much you need to borrow. Okay, so if I do the amount I'm going to borrow, 300 times this guy, because that's when you put all those numbers in and simplify or evaluate that expression, you're going to get the same thing. 905 ... Now, unfortunately, it's not in the top of my equation anymore, or my calculator anymore, so I'm going to have to type it all in. But 300 times 49. There's a, you can go back and stuff like that, but it's just as easy for me to type in those numbers. 14,971. That's how much I can borrow. Okay, but the car costs 21,000 to start with. But I can only, if I want my payment to be 300, I can can only borrow 14,971. All right, so this guy is 14,971.59. 245. If I take that amount borrowed, subtract it from the price of the car, I'll figure out how much I need to put down. So 21,000 minus second answer, $6,028.41 to the nearest dollar. $6,028. Monster problem. Interesting. You're going to drop your payment by $100 a month. Instead of putting down $1,000, you have to put down $6,000. So that's 5 problems. The rest are yours. We'll turn them in and then we'll go over them. I'll post all the solutions. All right, talk to you soon.